Alright, so this is the re-recording for Sprint 6. I did not realize it was too long until I was looking at the comments for the next week's video. Apologies. So first, in this video, I'm going to quickly go over the planning documents, address the criticisms from the previous sprints. For the game design document, I did do a little more detail on the levels, going into more specific things. For example, on level 3, I'm talking about building a wall for the terrain around the arena. It won't actually stop the player since I won't have that implemented, but it's just there to look pretty. So I'm talking about level layout. For the AI, the tank bots, I mentioned that everything's already done for them. I did that all last quarter. That's all complete. Within the plane bots, their AI is discussed under behavior and movement. Uh, I also go into a bit more detail on the HUD and also talking about implementing a level manager in order to keep track of everything. And my schedule is down here. For the particle system, I mean, it hasn't changed too much. It's just I have my class diagrams. I'm talking about what they're going to do. And for the most part, this has served me really well because it's planned out everything for me. The game planning document has actually done the same thing, despite the uh, how small it looks. I mean, I'm not talking about, for level 1, for example, I don't talk about specifically I'm going to have a hill here, a valley here. I don't go that in depth, but I do talk about some very basic things. So there's no enemies, I don't have to instantiate any AI managers, what the UI goal text will be, for example. Which has also been implemented this week. So that's the planning documents. This week we had to do the terrain as integrate terrain into our engine and also do the terrain rectangle iterator. So quickly, the scenes now each have a terrain scene manager. Base and the when the scene is created, under protected, so all the inherited members can use it. We have a set terrain. This basically just assumes that when the scene is created, we are setting the terrain and that's it. We're not ever going to change the terrain mid-scene. I think that's a reasonable assumption. Terrain scene manager is very, very simple. Set, get, and then the initialize and uninitialize, which only tells the terrain to submit and desubmit, submit a draw registration and deregistration. That's all it does. It's so simple, in fact, I probably could have thrown it in, just had the scene have a pointer to a terrain and just call the draw at the appropriate time, but I just decided to make up a scene manager just in case we want to do something with it later on, in case we want to scale up our terrain and make it do fancy stuff. Future-proof. And then I also had to change up the scene manager a little in order to have the initialized and uninitialized terrain get called whenever we're changing scenes. So there's that. For the terrain rectangle, so within the terrain first, we have our cell AABB. We now pre-compute all AABBs for the cells, and we store the min and max values of each AABB. We don't actually store the AABB because we can recreate it from the min and max values. So in order to save on space, that's what we're doing. We're just saving the min and max, and then later we can recompute the AABB very quickly. So we have it under a array, cell AABB list. We pre-compute all that. We have a few extra functions to help us later on. The terrain rectangle basically has the min and max x and z index, and then the begin and end functions, of course. Very simple here. Getting all of the stuff set up, equals operators and copy operators, and then the trect iterator. The trect iterator is very simple. We have all of our stuff. We have plus operators, equals and not equals to. We have the dereferencing operators. We have our x and z index, which is the current. We also have a pointer to the rectangle. And from there, it's very, very simple. Whenever we're plus, we check to see if, hey, are we at the max? If we are, go up a row. Same over here. Equals, we just check our index against theirs, assuming that our rectangles are the same. That's also very important. And then the dereference operators, we talk to the terrain attorney, which is part of which links it up to the terrain so that the user doesn't have access to these private functions. This is just for the inner workings. We want to hide that from the user. We talk to those functions. We get the cell, the cell AABB, which will give us the min and max values, which we can then use in our collision. So speaking of collision, we're going to hop over there to collision test terrain, which is a new group. The collision manager will also deal with that. So if we go in here, we can see we have a test cell, collision volume AABB, which again later we will reconstruct the data. We create a terrain rectangle. We have our iterator, which goes from the end all the way from the beginning to the end, iterating itself up. We set the data with the min and the max values that we get from the iterator, and then we test the intersection against that. And that's basically everything that we have so far. It all works integrated with the terrain, and all the user has to do is call set collision terrain right here. And again, it's basically like set collision self. It just registers the given group against the terrain. That's all it does. So it's very simple for the user to set the terrain up and to set collision with the terrain, and we handle all of the computing in the background without them having to do much of anything, really. In the original video, I was very, very proud of my animated sprite. With the foresight of what happens when I try to complete my particle system, this is completely useless to me. I was very, very close, but I'll discuss the problems with this, with everything about this in next week, because I don't want this video to go over again, and also next week, I fell a little behind schedule, so I have plenty of time to talk about this. So, we'll see this in action. I'm sure you'll probably figure out the problem with this before you even see my video. I was a little, I guess, naive. Anyways, moving on to what we've done for the game this week. We have our buildings, our building manager, which just keeps track of the number of buildings for the UI, because one of our levels keeps track of, okay, you have to destroy these 3 buildings. So that's what the building manager is for. The buildings register themselves and then deregister themselves so that it has the correct count. Goals are going to be used by the level manager later on. However, at the moment, the UI is in charge of goals because, as I said, each level has a different goal, and the UI is supposed to display that. So, for example, the first level, we have buildings that we need to destroy. So we have our kind of visitor pattern, I guess. We have a base class goal, which has a virtual function draw goal that the UI will call every draw frame. And then one of these 3, the boss, the bots, or the buildings, will be called, and then it will call on the UI, call on one of its specific functions, and then that will resolve itself into, oh hey, we want to figure out how many bots are left, so let's draw that in the goal position. It's just a way to remove an if statement every single draw frame. I just whipped it up real quick. It works fine. But it does also mean that currently the UI is in charge of whether or not we win the game. Later on, this might change. Alternatively, I could merge the UI and level manager into one, but we'll have to see about that in the future. Our first level is complete. We have a terrain, which we'll get into actually right now. So we have everything for the first level complete, as we'll see once it all compiles. I haven't run this in, well, a week. But as I said, level manager hasn't been really touched since the UI is currently in charge of that. If the level manager does end up being something we need that has to be complete, gold check will replace we'll be checking the goals, making sure that, you know, okay, a building has died, let's make sure that we haven't won the game. Um, and yeah, so there we go. So on our left here, we'll see our animated sprite working as intended. We can change the frame rate very easily with how we want it, and this is our first level. The terrain does end right there, so sadly the user can go over the edge fairly easily. In the future, this I guess will change. I'm gonna have to think of how to do that, but it's just gonna mean it's just going to require me making a larger image, I suppose. I wasn't quite expecting the thing to be so small, and I can't scale it up because this is kind of how I wanted it, so I'm gonna have to add on to it. As you can see below us, our terrain is still intersecting as intended. Everything's working as normal. These are the buildings I found. The models were great, however the textures, as you can see, are a little not okay. The texture came as one image. The model had UV mapping on it, and it only kind of kept itself together. So my current options are to either find a new model and texture, go on the search again. This one took me 2 hours to find. I'd rather not do that. Or to keep this and have its weird kind of wonky charm, or to replace the texture with something bland and simple like bricks. Currently I'm leaning towards either keeping the texture or replacing it, since I'd rather not go on a search for another building. As you can see, our UI is keeping track of goals as intended, and once we kill this, we win, and in the future this will advance us to the next level, but for now it simply boots us back to the main menu. So that's everything I've done this week, and next video will be, well, it should be up